Hi guys, so we have an O-level past paper question from the year 2016. The session is May-June. This is question number 8. In this question, we'll sketch the graph for a function, find the gradient and solve for x. So let's get into it. The question says the table below shows some values of x and the corresponding values of y for y equal to 1 over 4 times 2 to the power of x. Part A says complete the table, so we have to find this value of y for this value of x. When we plug in this value of x over here, this becomes 2 to the power of 1, which is 2. 2 times 1 over 4 is 2 over 4, which simplifies to 1 over 2 or 0.5. Okay, the next part says on the grid below, draw the graph of y equal to 1 over 4 times 2 to the power of x. So we have to plot these values on this grid right here. So let's do that. Where x is 0, y is 1 over 4. So where x is 0, 1, 2, 3, 4, this is here. Okay, the next is when x is 1, y is 1 over 2. Where x is 1, y is half. And then it says 2 and 1. So let's draw a line at point at 2 and 1. Then it says 3 and 2. It is increasing. Okay, then it says 4 and 4. Wow, that's a big jump. So it comes over here. And then it says 5 and 8, which is the point. 1 second, which is the point that is going to be over here. Okay, now let's connect these values with the straight line. Not a straight line, but a curve. So we start from this point and we go all the way like this. Okay, this is smooth enough. And we connect it to this point right here. Okay, I don't know whether it's the best of the curves that I've ever drawn, but this will do the job. The next part says by drawing a suitable line, find the gradient of your graph where x is equal to 4. That means we have to draw a tangent at x equal to 4. X is 4. Let's do this in black. So first of all, x is 4 over here, and on the graph it is going to be this value. So let's draw a tangent over here. Okay, this tangent is supposed to go somewhat like this. Okay, so let's draw this line. This is how it goes. This is how it crosses the curve. So at this point, let's take one of the values of x and y over here and the other value at this point. So this is 5 and 6.5, the coordinates of this, and this is 2.4 and 0. Okay, so let's plot these. We have these values. Let's find the gradient. So y2 minus y1 over x2 minus x1. Our values for y2 are 6.5 and y1 is 0. So you do 6.5 minus 0 over 5 minus 2.4. 5 minus 2.4. Let's see what we get as the gradient. We do 6.5 minus 2.4 and our value comes out to be 4.1, which is the gradient. 4.1. Okay, the next part says show that the line, wait, did I make a mistake? 6.5 divided by 5 minus 2.4. Oh, it's 2.5. Sorry, my bad. It's not 4.1, it's 2.5. Okay, so this is 2.5 and this is also going to be 2.5. The next part of the equation says, of the question says, show that the line 2x plus y equal to 6 together with the graph of y equal to 1 over 4 times 2 to the power of x can be used to solve the equation. And this is the equation. What they mean by this is, if we solve these two equations simultaneously, then I think we would end up at this equation. So let's do one thing. Let's do the substitution method. So I plug in the equation of the curve into this y value over here in the straight line. So I do 2x plus the entire equation of the curve, which is going to be 2 to the power of x over 4 equal to 6. Okay, then let's find the LCM. LCM on this side is going to be 8. This is going to be 8x plus 2 to the power of x equal to 6. We cross multiply this and eventually this is what we get. 8x plus 2 to the power of x equal to 24. Then we rearrange this. 2 to the power of x becomes the first number plus 8x minus 24 equal to 0. Hence, we prove this equation is similar to this. The next part says, hence solve 2 to the power of x plus 8x minus 24 equal to 0. In order to solve this, basically what they're trying to ask us is, we need to find the point of intersection of the straight line and the curve. So we'll use this equation. Let's do this part in red. Okay, just to distinguish it. So we use 2x plus y equal to 6, or we rearrange this to make it y equal to negative 2x plus 6. We put down two values of x, let's say they are 0 and 1, and find two different values of y. So when x is 0, y is 6, and when x is 1, y is going to be 4. Let's plot these two values on the grid. So when x is 0, y is 6. It is going to be over here. And when x is 1, y is 4. X is 1, y is going to be 4. Okay, the easier and the best way to do it is you draw a straight line and you see where the line and the curve intersect, and that is going to be the value of x. So we draw a straight line like this. Okay, one second. So this point right here, let's say that this is going to be between 2.3 and 2.4. Let's assume that this is 2.4. So x is going to be 2.4. Okay. The next part says the points P and Q are 2, 3 and 5, 4 respectively. Find the gradient of PQ. So in order to find the gradient of PQ, you need to subtract y2 and y1 over x2 and x1. y2 is going to be 4 minus 3 over 5 minus 2. The gradient comes out to be 1 over 3. The better way of doing this is, let's do this in blue. The better way of doing this is, let's plot these 2 points and connect them through a straight line, because that might be used in the question after this. So we draw a point at 2 and 3 over here. Okay, and then we draw a point 5 and 4. 5 and 4 is supposed to be over here. Okay, let's connect this using a straight line so that we remember what we're doing. One second. Okay, so this is the straight line that we get for this. Let's read the question. I'm not going to erase the scale. On the grid, draw the line L parallel to PQ that touches the curve y equal to 1 over 4 plus times 2 to the power of x. What the mean is that the line that we just drew, this blue line, we need to draw a line parallel to this using a ruler and just our imagination. That would be a tangent to the curve. So let's see where that tangent is. So this is the point. That point is going to be 1 over here. This is the tangent that they are talking about. This line is parallel to PQ, and let's call this line L. This line is L over here, and the point of intersection of the tangent and the curve is going to be 1 and 0. Perfect. So we have done this part. Now it says write down the equation of L. So in order to write down the equation of L, first we need the gradient. We have the gradient, which is 1 over 3 because it's parallel to PQ, so it's going to be 1 over 3. Then we can use this equation, y minus y1 equal to gradient times x minus x1. We have the x and y values over here because the point of intersection was 1 and 0. Sorry, was it 1 and 0? No, it wasn't 1 and 0. It was 1 and 0.5. My bad. So it is going to be 1 and 0.5. And over here it is also going to be 1 and 0.5. So that makes it not on the y or x axis. Anyways, so you do y minus 0.5 equal to 1 over 3 times x minus 1. 3 goes to this side, gets multiplied, so you get 3y minus 1.5 equal to x minus 1. Then this 1.5 goes to the other side, gets added to negative 1. So your final equation becomes 3y equal to x plus 0.5, and you can write it over here, 3y equal to x plus 0.5. Sorry, I forgot to write the answer over here. The gradient was 1 over 3, and you're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.